So on this figure here, I'm going to ask you to find three things. One, I'm going to ask you to find x. Two, total area. And three, we're going to switch it up a little bit. I'm going to ask you to find the perimeter. Where do we start? Well, we look for right angles, and where are the right angles when we have circles? We can make rectangles, and to find the right angles for the rectangles, we make a radius out to a point of tangency. Those all form right angles. Now, to make a rectangle here, I can't connect the centers. If I connect the centers here, this, of course, is 0.55. Where'd that come from? Half of the diameter, 1.1. This is, of course, over here, this one is 0.9. Half of the 1.8 diameter. So that's not a rectangle right now because those opposite sides are not the same length. Do I cut it like this to make this 0.55 so it's the same length? Does that work? Will that blue line work?
No.
No, because this was a right angle here, and when I cut that, I made that smaller than a right angle. So what I would have made, there's a parallelogram, not a rectangle. I want to make it a rectangle, so I want to keep, these two angles are right angles, so I want to keep them. So I don't want to cut into either of those angles. So I'm going to cut it across here so that these are right angles. That will make this here the 0.55. That makes this piece up here then what? Careful. 3.5, right? Because it adds up to the 0.9. In that triangle, the right angle is here. Because this is a right angle. That one has to be a right angle. So I have this triangle. This is 0.355, just 0.35, not 355. What other side do I have here? 1.24. Where does that go? Up here or down here? That goes up here. Very good. This side is x. Because that'll be this side, which is the same as this side because they're opposite sides of a rectangle. This is just going to be a squared plus b squared equals c squared. 0.35 squared plus x squared equals 1.24 squared. At this point, I'm going to assume you guys can do that, solve that from there. So I'm just going to punch in the square root of 1.24 squared minus 0.35 squared equals, and we're going to get x of 1.18. I'm going to have to go 1896 here. That's going to be inches. So that's my first one. I found x, 1.1896 inches. Probably 1.190 is where I would really round that off. Area. Well, I've got piece 1 here. Of course, up here there's another one that's also the same shape, exact same shape. So piece 1 is 0.55 times 1.1896 times 2 because there's 2 of them. Is 1.309, we're going to call that square inches. We're going to call this here piece 2. There's 2 of them. That's just this triangle over here. So that's going to be 0.35 by 1.1896 divided by 2 because it's a triangle, but then times 2 because there's 2 of them. And yes, you could just skip the dividing by 2 because the divide by 2 and times 2 are going to cancel out. So 0.35 times 1.1896 divided by 2 and times 2, 0.416 square inches. So far, really no trig involved. I mean, the Pythagorean theorem is technically part of trig, but we didn't do any trig functions. The trig functions in this one come into play finding the angles. We need to find this angle here and this angle up here. To do that, we're actually going to find this angle, which will be the same as this one. And to do that, we're going to find this angle, which I'm going to move over here. Is that angle there off that triangle. I find that angle, that'll be the same as this one. I double it, I get that whole angle. So there, I'm going to use the pieces that were given. So I have the hypotenuse, 0.35, opposite or adjacent? It's adjacent, because we're looking at this angle. So adjacent and hypotenuse is going to be the cosine. So cosine of that angle is 0.35 over 1.24. We're looking for the angle, so this is going to be an inverse cosine. So that angle is second cosine, 0.35 divided by 1.24. 73.60. Squeeze. Yes.
Now I got to that angle by having my theta be the point
Down here?
dissected, yep.
Mm-hmm.
And then so I took two of those.
Mm-hmm.
And that shape is a 360.
Yep.
And you got 290s. So then you just subtract that from 360.
Yep. Yeah, this angle here and this one here have to be supplements because of the way it's drawn out. Yep, that works. So that's 73.6 degrees. We're going to double that.
Wait a minute, what do you use cosine?
Because this is I'm looking at this angle, so this is the adjacent side. So I double that angle. That gives me 147.21. So this angle here, 147.21 degrees. Excuse me. Now you notice this was 73.6, but I left it in the calculator. I didn't round it off and type it back in. When I doubled it, it comes up to 0.21 instead of just 0.20. So that saved me a little bit of round off error there. If that one's 147.21, this one over here is 360 minus that. So that would be 212. .79 degrees. So then, for piece 3 here, that circle has a radius of 0.5, so that's pi times 0.55 squared. That's the area of the circle. That'll be times that angle, 146.21 over 360. So 3.14 times 0.55 squared. Give me just a second. Gives me the 0.3858. Is that what you had? It is 147. Thanks. So 0.3884. 0.388. We're going to go. We're going to round it off there. Any questions so far? Bless you. Number 4 then is going to be pi times that radius of 0.9 squared times that angle is 212.79 over 360. So 3.14 for pi times 0.9 squared times 212.79 divided by 360. 1.503. This is squared. That all adds up to 3.716. Does that look right? So that would be the area for that. So 3.716 inches squared. Perimeter. We've really done all the heavy lifting for perimeter. I can actually squeeze that calculation in right here. For perimeter, we have X, which is 1.18. I'm going to round it 1.190. We have another X up here that's 1.190. This arc is going to be the perimeter of the circle. Pi times 1.1 times that angle, 147.21 over 360. I'm going to do that up here. So this arc here is pi times the diameter of 1.1 times that 147.21 over 360. Giving us 1.412. Then this arc over here is going to be pi times that diameter of 1.8 times the 212.79 over 360. Yeah, just change the angle and change the diameter. So 3.341. So that all adds up to give us 7.133 inches is the perimeter. Any questions? If you want to start it, does everybody agree they want to start the test, or do you want to see the bottom problem? Let's do the test. Let's do it.